Hello friends, welcome to our channel Knowledge Amplifier, and in my this particular video I am going to discuss one very popular machine learning algorithm, and that is support vector machine, widely used to classify our unknown data point into one particular class among two known classes. Okay, like for example here if you consider in two-dimensional plane I have some data points which are coming under this cross class and some data points coming under circle class. Now suppose one new data point comes for which we don't know which in which class the data point belongs, and we need to decide that using some machine learning algorithm. Then we can use support vector machine. So what support vector machine does, it basically try to find out one hyperplane. Okay, hyperplane is nothing but you can consider one simple plane which basically using which we try to divide our two classes properly. Okay, like here if you consider this is one sector and this is another sector. Now one good divider line in between these two classes can be this particular blue line. Okay, right, this is called hyperplane in this case. Okay, no need to go with the term, no need to confuse yourself. In two dimension the plane is nothing but straight line, right? If you consider three dimension, that will be space. Okay, what we have studied in our class 12 vector syllabus, vector and 3D geometry, right? Now see here, this is one possible straight line which is perfectly segregating or basically acting like divider in between these two classes, cross and circles. Now there is one more possibility like this kind of straight line B2, which I have given the name B2. Okay, similarly there are much more possibilities, you can understand infinite possibilities actually between B1 and B2, and this kind of line also possible. Now which one to select? Okay, because this selection of the line is most important. Once we select the line, we will basically suppose getting one new point. If the new point is placed here suppose, then in that case we will tell that this, or we will conclude that this particular point is belonging to this class. Suppose our new data point which is coming is situated here, then we will consider this point as member of this circle class, right? Now so the factor which is most important is finding out this hyperplane or this straight line in this particular case. The idea to select this particular which plane to choose for our machine learning depends on support vectors. So what is that? See, what we will do basically, suppose this is our hyperplane. For the time being consider this one. Now draw two parallel lines, okay, or parallel plane in general we can say, which will pass through nearest points present in two classes. Okay, like here this point is closest to this particular original line, so we have drawn one plane here. Okay, parallel plane of our this particular original hyperplane. Okay, here also for this particular class this point is nearest, so we will draw one more parallel plane via this particular circular point, right? Now the gap or distance between these two parallel planes, okay, is called margin, and the idea to get proper hyperplane is maximize the margin. Okay, now you can clearly understand for this B1 straight line obviously margin will be more because these nearest points are basically comparatively at larger distance. But if you consider B2 as my hyperplane, see the nearest cross point is here, that is distance will be this much from this particular hyperplane, and for B2 for the circle class this particular point is nearest. Okay, so basically here you can understand that maximum margin can go like this much only, so obviously this is not good selection. Okay, so obviously we will select B1. Okay, if there is possibility to draw more better way, obviously we will choose that. Okay, and you no need to think about that algorithm how it will go. MATLAB inbuilt function will do that for us. For us the important part is train our model properly with proper data set without any outliers or null values, so that the accuracy will be very high. Rest part will be handled by MATLAB itself. Okay, And what is support vectors then? Because the name itself is support vector machine. So what is support vectors? Support vectors are basically points belonging to two classes through which the planes, the parallel planes are passing. Like here, this particular point in the cross class, here this particular plane is passing, right? Here for here this particular circle class, via this particular point this plane is passing, so that these are called support vectors. And it need not be only one data point, there may be multiple data points placed on this particular plane, and same goes for here. Whatever point will come on those nearest planes, those will be termed as support vectors. Okay, now here in this particular case we can simply separate these two class using one linear plane, right? So linearly separable we say. Now there are many times in our data set it will appear that the planes are not exactly linearly separable. Suppose some cross points come in this region, some circle points come in this region, right? Then what is the problem? Then one simple way is, with some misclassification, try to adjust your model. Okay, there will be some misclassification, but we can avoid that. There is one way. Another way is using kernel. Okay, what is that? I am going to discuss now. So up to what we understood, that find hyperplane which maximizes the margin, like B1 is better than B2. B1, this one is better than B2. This idea we have got, right? Now coming to misclassification. Okay, so here if you consider, I am just showing in one dimension. Okay, so suppose there are two box, there are box class and circle class. Okay, suppose two box class here, then four data point belonging to circle class here, and here two box classes. Now here if you try to think one straight line like this which can classify, then here almost 50% misclassification will happen, right? Because these 2 points will be misclassified. Here if you consider your hyperplane, then here also these 2 points will be misclassified, right? So in this case what we will do? In this case we will convert this particular data set to higher dimensional data set. If it is one dimensional, we will map to two dimensional. If it is two dimensional, we may map to three dimensional, four dimensional. Okay, when those will be separable, when there is possibility of separation, then we will stop. Okay, so like here in this particular case, what we can do? We can think about one parabola in two-dimensional plane, and we will map all these data points which are basically in one dimension. We'll map them in two-dimensional parabola. Now you see this particular box will map here, this particular box data will map here, and all these circles data will come here, and these boxes will map here. And see now in this case here perfectly one line we can pass via two-dimensional plane, which is basically segregating our this box data point and circular data point, right? Yes or no? Right? I hope you have understood. So basically these are called kernel. Kernel is nothing but some particular mathematical equation which will map our lower dimensional data point to higher dimension. Like here we are using y equal to x square. Okay, for mapping lower dimensional, that is one dimensional data point to two dimensional data point, right? That's the simple idea. Suppose I am having this kind of data set in two dimension. Okay, you can understand this is not at all possible to classify this particular data set linearly. Okay, there is no straight line you can draw, right? Like here if you consider this kind of straight line, then almost accuracy will be less than 50%. Then in this case what we'll do, we'll consider one parabola in three dimension or space. Like here I can show you. Here if I just open the support vector machine in Wikipedia, okay, here we can go this particular image I can show you. Yes, see here some red points belonging to one class and blue belonging to another class. What we can do, we can map this to three-dimensional parabola type. So red points are coming in the lower part and blue points are coming in the upper part. Okay, like this we can map. All right, then there is in two dimension itself there is possibility of non-linear separation. Like we have seen using only straight line we are separating our two classes, right? But if you as you know that polynomial regression have more accuracy than linear regression, same type of concept you can map here. This is our linear regression kind of thing. Now if you try to fit polynomial line, there is non-linear fitting, that will classify our or segregate our two classes in a more better way. Okay, so these are some important concepts related to SVM. I hope the fundamental concept you have understood. The idea is nothing but unknown data point comes, we need to apply classification technique to map that particular data point into one of our well-known classes, either class A or class B. Okay, so majorly it is used for two class classification. And what we will do now next in our this next video, I will be showing you MATLAB implementation of SVM, and we will try to do some real-time project also. Okay, this is all for my this video. Thank you for watching.